Hi student, 12th physics, chapter number 4, electromagnetic induction and alternating current. In this video, we are going to discuss about AC generator. So, AC generator, it is a device that convert mechanical energy to electrical energy. In this AC generator, based on the principle of electromagnetic induction, electromagnetic induction, already you know, where there is relative motion between conductor and magnetic field. Are you clear? Now see, electromagnetic induction, that is whenever amount of magnetic flux linked with the coil changes, an EMF is induced in the coil or in the circuit. So the magnitude of induced EMF is given by Faraday's law of electromagnetic induction. It is clear. And direction of magnetic field of induction of Fleming right hand rule. Now we are going to main part of the AC generator. So it is stator, rotor, alternator, brushes and slip ring. Now here stator and rotor, this is a stator and rotor, are they very important of AC generator. This two is very important of AC generator. So it is commercial generator will have a stator and a rotor. Stator is a stationary object and a rotor is a part of rotate inside of the stator. Now we are going to see construction of AC generator. So there are two main part of the AC generator. One is a stator and a rotor. Now in details regarding stator, we are having a metal frame. Now see, this is a stator frame. The frame of the stator, this frame of the stator, when the stator or large number of ventilation hole, a good ventilating provided for the armature coil. This is called a ventilation hole. Inside the frame, we are having core of stator. This is nothing but stator core. Is made up of steel or iron. Understand students? This is stator core made up of steel or iron. This core, a large number of slot. This armature core, so this armature core made up of iron or steel. It is kept inside the frame of the stator. It has large number of core where armature coil of mounted this core. This is the construction of stator. So students, the stationary part which has armature winding mounted in it is called stator. It has three components, namely stator frame, stator core and armature winding. Now first of all, stator frame. This is the outer frame used for holding stator core. This is outer core. This is nothing but stator frame holding stator core. This is stator core and armature, winding of armature in proper position. Stator frame provides the best ventilation hole with the help of the hole provided in the frame of itself. Then stator core made up of iron or steel. It is a hollow cylindrical shape and is laminated core, using laminated core. Why? What is the uses of laminated core? Because of minimize the eddy current. So already you know that how to minimize the eddy current can be used to laminated core. The slot are cut on inside surface of the core to accommodate armature windings. It is clear? Okay. Now stator core with a rectangular loop, that means armature coil, and stator core with a armature winding. Now see, this is a winding of the coil. This is stator core winding of the coil. This is outlet terminal. Okay, now armature winding is the coil wind on slot provided in the armature core. One or more than one coil may be employed depending on the type of alternator. Two type of armature winding commonly used: single layer winding and double layer winding. In single layer winding, a slot is occupied by a coil as a single layer. Now see, this is a single layer. But in double layer winding, the coil are split into two layers, such as top and bottom of the layer. It is clear? Next, construction of AC generator rotor. There are two types of rotors used in alternators or AC generator. The first type of rotor, salient pole, and second type of rotor, cylindrical pole. Now first of all, salient pole rotor. We are having magnetic field coil, magnetic field armature or coil. Rotor is having axis. This is nothing but axis. The axis rotating with a constant speed. To this axis having two slip ring. This is a slip ring S1. We can take a S1 and S2. When the axis is rotate, these slip rings also rotate along with the axis. Understand, student? When the axis is rotate, the slip ring also rotate along with the axis. Axis of rotor, we are having core, armature core. This salient core has magnetic field winding with one end. This is a north pole of the magnetic field and south pole of the magnetic field. One end of the coil is connected to slip ring 1. This is a slip ring 1 and another one is connected to another end of the pole, magnetic pole, that means south pole. So magnetic field winding with one end of the coil is connected to slip ring 1 and another end of the coil connected to slip ring 2. When this coil rotate, slip ring rotate along with the axis and salient core. So students, the salient core or pole. The word salient means projective, that means projection. This rotor has number of projecting poles having their base riveted to the rotor. So okay, this rotor, salient rotor, low voltage generator, salient pole rotor, it is a low voltage generator. This salient only two pole rotors, only two pole. Now see, north pole and south pole. Okay, then second type of rotor, cylindrical pole rotor. This rotor consists of solid material. That means we are having cylinder, solid cylinder, and it has large number of cavities. Now see, cavities means slot. The slot are cut on the outer surface of the cylinder along its length. It is suitable for very high speed alternator. So student, this cylindrical pole rotor high voltage generator because of the frequency of alternating induced EMF is directly proportional to rotor speed, that is constant. In order to maintain the frequencies constant, the rotor must run at a constant speed. Note it down student, it is a very important one. One more question. The frequency of alternating induced EMF. Now taking frequency nu, we consider nu is directly proportional to speed, rotor speed v. In order to maintain frequency is constant, the rotor must run at a constant speed. Both are constant. Are you clear? So this is nothing but a cylindrical pole rotor connected to the DC supply with a axis. So these are standard construction details of AC generator based on the type of alternator being constructed. So many types is there, number of poles, pole types, number of coils and type of winding would change from one another. Are you clear children? Okay, next we are going to advantages. Advantages of stationary armature rotating field alternator. There is nothing but a AC generator. AC generator are generally high current and high voltage machines. The stationary armature rotating magnetic field. The construction of AC generator has many advantages. Now we are going to discuss few advantages. The first advantages of AC generator, the current is drawn is directly from fixed terminal on the stator without using brushes. The second advantage of the insulation of stationary armature winding is erased. So already you know that a laminated core. What is the uses of laminated core? Because of minimize the eddy current. Are you clear? The third advantage is the number of sliding contacts. Sliding is nothing but slip rings. Number of slip rings is reduced. Moreover, these sliding or slip ring contact are used to low voltage DC supply. In fourth advantages, armature winding can be constructed more rigidity to prevent deformation due to any mechanical stress. Are you clear children? Okay students, hope you understood. Then tell me, answer my questions. I give the principle of AC generator. And second one, I list out the advantages of stationary armature rotating magnetic field system of AC generator. It is 2 more questions. You write 4 advantages. How will you induce an induced EMF? By changing the area enclosed by the coil. It is 3 more questions. Then show mathematically that the rotation of the coil in a magnetic field over one rotation induce an alternating induced EMF of one cycle. So this is a very important 5 more question. There is nothing but orientation of the coil with respect to magnetic field.